Hello friends, this is Rashmi Singh. Welcome to my channel Unraveling Science. Let's have a moment of science please. No one is born a winner or loser, but each one is born a chooser. Today's topic is magnetic effect of electric current. Class 10, Chapter 12. In this video, we are going to learn about what is magnet, magnetic field, magnetic effect on straight current carrying conductor, right hand thumb rule, magnetic field due to flow of current through circular loop, magnetic field due to current flowing in the solenoid, Fleming's left and right hand rule, electric motor and electric generator, electromagnetic induction. What is a magnet? A magnet is an object that attracts or repels other magnetic materials such as material made of iron, cobalt, nickel with magnetic field. As you can see in the picture, there are many types of magnet: horseshoe, bar, disc or ring magnet. Properties of magnet. When suspended freely, a magnet rests in north and south direction. North pole of the magnet points towards the north and south pole of the magnet points towards the south. Like pole of magnet repel each other while unlike poles attract each other. Magnetic field. The area around the magnet where the magnetic force is experienced is called magnetic field. It is a quantity that has both direction and magnitude. That's why it's a vector quantity. There are three types of artificial magnets: bar magnet, magnetic needle, magnetic compass. Characteristics of magnetic field lines. Direction of the magnetic field emerges at the north pole and merges at the south pole. The magnetic field lines are closed curves. The degree of closeness of the field line determines the relative strength of magnetic field. The more crowded the lines, stronger the field. Magnetic field lines do not cross each other. Hans Christian Ørsted. He was the scientist who showed that electricity and magnetism are related to each other. His research later used in radio and television, etc. The unit of magnetic field strength is named Ørsted in his honor. In his experiment, he showed that on passing the current to copper wire in a circuit, the compass needle which is placed near the conductor gets deflected. As you can see in the picture, if we reverse the direction of current, the compass needle will deflect in reverse direction, and if we stop the flow of current, the needle comes to rest. This shows that electricity and magnetism are linked to each other, and whenever the current will flow through the conductor, the magnetic field will develop. Magnetic effect on straight current carrying conductor. A straight current carrying conductor has magnetic field in the shape of concentric circles around it. The direction of magnetic field produced due to the current carrying conductor rely upon the same direction in which the current is flowing. The direction of magnetic field gets reversed if the direction of electric current changes. So as you can see in this diagram, when a straight current carrying conductor is hung vertically and electric current is flowing from north to south direction, that is from up to down, in this situation the direction of magnetic field will be clockwise. And if the same current is flowing from south to north direction through the same conductor, then the direction of magnetic field will be anti-clockwise. The direction of magnetic field in electric current through a straight conductor can be represented by using right hand thumb rule. According to this rule, if you are holding a straight current carrying conductor in your right hand such that the thumb points towards the direction of the current, then your finger will wrap around the conductor in the direction of the magnetic field lines. The right hand thumb rule is also known as Maxwell corkscrew rule. As you can see in this diagram, if we consider ourselves driving a corkscrew in the current direction, then the corkscrew direction is in the direction of magnetic field. Magnetic field due to the flow of current through circular loop. As you can see in this diagram, the magnetic field produced in the circular current carrying conductor is same as that in the straight current carrying conductor, and the current carrying circular loop will behave like a magnet. As we move away from the wire, the concentric circle appears larger and larger, and at the center, the circular coil, the arc appears as a straight line. The magnetic field is the strongest near the periphery of the loop. You can see the periphery of the loop, and the magnetic field on the coil depends directly on the current passing through it. Therefore, if the coil has n number of turns, then the magnetic field will be n times larger. Magnetic field due to current in a solenoid. A solenoid is a tightly wound helical coil of wire whose diameter is smaller than its length. The magnetic field produced by the current carrying solenoid is similar to a bar magnet, that is, the magnetic field produced inside the solenoid is also parallel, which is why when one end of the solenoid behaves as south pole, the other behaves as north pole. The stronger magnetic force produced by the solenoid can be used to magnetize a piece of magnetic material, and the magnet so formed is called electromagnet. The difference between electromagnet and permanent magnet is electromagnet can be easily demagnetized, whereas permanent magnet cannot be demagnetized. Electromagnet polarity can be reversed and strength is varied. In permanent magnet, polarity cannot be reversed. Electromagnets are strong magnets and permanent magnets are weak magnets. Force on a current carrying conductor in a magnetic field. An electric current flowing through the conductor produces magnetic field, and the field so produced exert a force on the magnet placed in the vicinity of the conductor. The magnet also exert an equal and opposite force on the current carrying conductor. The displacement of the rod in the diagram suggests that the force is exerted on the current carrying aluminum rod when placed in a magnetic field. Here the direction of the force is also reversed when the direction of electric current through the conductor is reversed. The direction of force on the conductor depends upon the direction of current and the direction of magnetic field. The displacement of the rod is maximum when the direction of current is at the right angle to the direction of magnetic field. Fleming's left hand rule. As shown in the diagram, according to this rule, when you stretch your thumb, index finger and middle finger of your left hand such that they are perpendicular to each other, then the index finger will point in the direction of magnetic field, middle finger will point in the direction to the current, and the thumb will point to the direction of force in the conductor. Electric motor. An electric motor is a device that converts electrical energy into mechanical energy. Electric motors are used in electric fans, various toys, and for pumping water. Electric motors are of two types, AC motors and DC motors. Principle of electric motor is that when a rectangular coil is placed in a magnetic field and current is passed, the coil rotates continuously because of the force acting on it. The shaft attached to the coil also starts to rotate because of the rotation of the coil. So as you can see in this diagram, this consists of following parts. First is armature, which is a rectangular coil ABCD which is suspended between two poles of magnetic field. The electric supply to the coil is connected with the commutator. Commutator or split ring is a device which reverses the direction of flow of electric current through the circuit. It is two halves of same metallic ring. Magnetic field supplied by the permanent magnet Ns. As you can see in the diagram, the current enters into the coil ABCD through a source battery through conducting brush X and Y flows back to the battery through the conducting brush Y. Working. When an electric current is supplied to the coil of electric motor, it gets deflected because of magnetic field. So as you can see in the picture, as it reaches halfway, the split rings which acts as a commutator reverses the direction of flow of electric current. Reversal of direction of the current reverses the direction of force acting on the coil. The change in direction of force pushes the coil and it moves another half turn. Thus the coil completes one rotation around the axle and the continuation of this process keeps the motor in rotation. Electromagnetic induction. Michael Faraday made a breakthrough discovery of how a moving magnet can generate electric current. Electricity produced as a result of this is known as electromagnetic induction. So definition of this will be when a conductor moves inside the magnetic field, or alternatively when the magnetic field changes around the conductor, the current is induced in the conductor. And when the conductor is brought in motion because of the magnetic field, a potential difference is induced. This phenomenon is known as electromagnetic induction. So you can see the current is induced only on the movement. If there is no movement, there is no current. Fleming's right-hand rule helps explaining the electromagnetic induction. According to this rule, when an index finger, middle finger and thumb are held in such a way that they are mutually perpendicular to each other, then index finger will point in the direction of magnetic field, middle finger points in the direction of current induced, and the thumb will point in the direction of movement of conductor. Electric generator. It is a device which converts mechanical energy into electrical energy. Electric generator are of two types, AC and DC generator. Electric generator works on the principle of electromagnetic induction. Working. The structure of electric generator is similar to that of electric motor. In case of electric generator, a rectangular armature is placed within the magnetic field of permanent magnet. So as shown in this diagram, this armature is attached to the wire and positioned in a way that it can move around an axle. When the armature moves within the magnetic field and electric current is induced, the direction of the induced current changes when the armature crosses halfway mark of its rotation. Thus the direction of current changes once in every rotation. Due to this, electric generator usually produce alternate current, that is AC. To convert an AC generator into DC generator, split ring commutator is used, which helps in producing direct current. Difference between AC and DC current. As you can see in this diagram, AC current, electric charge flows changes its direction periodically, and in DC current, the current does not change periodically. In AC current, the rotating magnets cause the change in direction of electric flow, whereas in the steady magnetism makes the DC flow in a single direction. AC current is easy to transfer over longer distance, even between two countries, without much energy loss. Whereas DC cannot be transferred over very long distance, it loses electric power. The frequency of AC current in India is 50 to 60 Hz. DC has no frequency or zero frequency. Advantage of AC over DC. Cost of AC is much less than that of DC. AC can be easily converted to DC. AC can be controlled by the use of choke, which involves less loss of power, whereas DC can be controlled using resistance, which involves high energy loss. AC can be transmitted over long distances without much energy loss. AC machines are stout and durable and do not need much maintenance. Disadvantages of AC. AC cannot be used for electrolysis process or showing electromagnetism as it reverses its polarity. AC is more dangerous than DC. Domestic electric circuits. In our household, electricity is supplied to the main supported by poles and cables. There are three types of wires. Live wire, which is red insulated and positive. Neutral wire, which is black insulated and negative. Earth wire, which is green insulated, which prevents any leak of current into the metallic body and ensure user doesn't get serious shock. So a schematic diagram of one of the common domestic circuits is shown here. So here you can see the green wire is the earth wire, red wire is the live wire, and the black wire is the neutral wire. Short circuit. A short circuit occurs when a live wire and neutral wire comes in contact and a large current flows. This happens due to either damage of insulation power lines or faulty appliances. Overloading. When the current drawn is more than the current carrying capacity of the conductor, it results in overloading. Causes of overloading are accidental hike in voltage supply, use of more than one appliances in a single socket. Electric fuse. It is a protective device used for protecting the circuit from short circuiting and overloading. It is a piece of thin wire of material having low melting point and high resistance. Fuse is always connected to live wire. Fuse is always connected in series to the electric circuit. Thanks for watching. Please do like, share and subscribe.